So welcome back to Stars Talks in Genova 2020. Now I introduce the next two sessions. We talked before about human, then micro, and now we explore the macro. Sonifying the cosmic signals. The speakers are Stavros, Katsanevas, and the EGO director, and two artists, Evelina and Dimitri. So I call them on the stage.
So thank you, and my excuses for all this trouble. As I said, Hopin and myself are not in good mood, and it's not the first time it happens to me. Anyway, so listening to the cosmos, can blind people do it better? Let me start with a rather talkative and busy slide to remind you that our relationship to the sky has passed through many stages, from the projection of the familiar to the sky, which is the zodiac, and our embedding through our rhythms to the rhythms of the sky through astrology, to Thales that started the geometrization of the sky, and Pythagoras that went through the arithmetization, invented the celestial harmonies, that you can find their story going through many cases, including the Renaissance here in Italy. And then by the 1600s, Galileo and later Newton and Descartes start the fundamental principles of mechanics, and therefore it is a full geometrization, mechanization of the world picture, and it is the start of astronomy. Quite later, 3 centuries later, when we managed to analyze the light through spectroscopy, we started understanding that these sublime events that were happening there, the luminous events, were actually stars, and they had an internal structure. And this suddenly became, from astronomy, we went to astrophysics. It was not an easy passage. It is a full story around it, but I don't have the time to talk about it. And then, in the early 20th century, as it was already said, there were two major theories that extended the Newtonian image of space-time, which was a fixed framework, to either space-time as a deformable medium, a medium that can be deformed through gravitation, therefore gravitational waves, or eventually a product of entanglement. You've heard things right before. In the 30s, these two theories were used to understand the physics of the stars. So we can say that we started uniting the two infinities, the infinitely small and the infinitely large. And after the 50s, a whole series of new instruments, radio telescopes, gravitational wave detectors, neutrinos, large cosmic rays, started to reveal a dark and violent landscape, conditioning the formation and structure of the cosmos. This, we can call it era of the astroparticle, we can call it whatever we want. The question is, can we attempt a new cognitive, affective, and conceptual synthesis of this? Let me remind you some of the violent phenomena. For instance, a star at the end of its life can either become a neutron star, a black hole, or simply a white dwarf, depending on its mass. We have also other black holes that are the centers of galaxies that can accrete mass, and therefore they can also create jets and create violent stuff. And probably one of the violent events to which our life is due is, of course, the Big Bang, which was the origin of structure. Now, what is the Big Bang? You have a violent change at the origin of the visible universe from the vacuum, creates waves, and actually by chance, when we started seeing these things, we started seeing them through Penzias and Wilson, it is 400,000 years after the initial moment, and at the time, their let's say, speed of perturbation, it's very close to the acoustic. So when we make an analysis of the perturbations of the Big Bang, we are very close to an acoustic analysis. So this, you can call it, if you wish, the remnant of the celestial harmonies. But I followed the previous talks. It was more Xenakis than, let's say, Bach. It was, a noise. And actually, a colleague of mine took, and this is one of the things we will be doing, took this thing, which is the primordial fluctuations due to the satellite Planck, and made, I'm sorry, I will try to do it. I don't know if you hear it. Try to sonify it. So you hear how it would look. And actually there is a joke about it. I'll stop it because we don't have a lot of time. I stop it. Isaac Bashevis Singer, who was a literature Nobel, took at the same time with Penzias and Wilson the Nobel Prize and asked them at the table, is it you that have heard the Big Bang? And immediately Penzias and Wilson went back and made a sonification of their signal. But this is illustration. It's not a new tool. And this is what I would like to show you further down. Then what about dark phenomena? We have the black holes, we have dark matter, we have dark energy, which are the scaffolding of the universe. And you see there are a lot of Nobel Prizes going around it. And some Nobel Prizes that were never given because the dark matter one, we still have not spotted down what it is, the dark matter, and is it black holes? Is it new types of matter? We're still working on that. But also, therefore, the black, if I make a joke again, I can say that the new physics is a psychoanalysis of the universe because it tries through the dark and violent parts to understand the formation of its structure. Actually, you could say in the youth. So we have now, and this is where I wanted to tell you, we have now new ways to sense the universe, and we call it multi-messenger astrophysics. And you have in this table all the frequencies where we can probe the universe from a frequency which is one event in the whole life of the universe to a frequency which is very, very, very high, which is the smallest frequency, the smallest time that we can define, which is called Planck. And in between, you have acoustic signals, which are the signals we can hear between 10 and 20 kilohertz. You have electromagnetic signals, which was the standard astronomy. Of course, we started with the visible light. And you have also cosmic rays at the high energies, where you see that. So if you make again the metaphor of this, you see it, I made it just for you. If you construct a piano to play the new celestial harmony, we would need 61 meters. I put 1 centimeter per note per tenth of a decade. And you see that we try these days to understand the universe in all the frequencies that are available, because each frequency depends on what happens, the dimension of the object that happens. Let's go now to Einstein's theory of gravity. As I said, space-time is deformable. Therefore, something, mass and energy, change the space-time, but they change it through, you see here, a constant that it is very small, 10 to the minus 43. Therefore, in order to see something, you can see it only with cosmic events. You cannot make a Hertz experiment. You cannot start communicating on Earth as you would do with Marconi, because you need a lot of mass, a lot of energy to do it. And these are the things you see. You see when you have two black holes with two neutron stars coalescing, continuous sources that spinning neutron stars, supernova, and as I said, why not the cosmic background from gravitational waves from the initial Big Bang. For the time being, this is a little bit far from us. And this was what we saw. This is what we saw in 14th of September 2015. And you see here that the frequencies were exactly acoustic from, let's say, 10 to 500. So this made us use very often the metaphor that we've heard for the first time the universe. Of course, it was not sound that came. It was, I will show it to you later how it happened. But okay, you understand here, you have the event, you have the coalescence that makes ripples in the time, and they arrive to Earth, and they make even the whole Earth trembling. But this trembling is so small, it is 1,000th of the diameter of a proton. So you have to have very sensitive instruments to see it. And these were the instruments we had when we saw it. Now, the second thing we saw, which was fantastic, was the fact that we saw two neutron stars. And when we saw the two black holes, since they are black holes, very little light comes out. But if you have neutron stars, it was an explosion. And this explosion, it was seen by us, and then around 70 observatories at the visual, at the radio, at the electromagnetic saw it at the same time. So that was named, the 17th of August of 2017, the initial date of multi-messenger astronomy. And let me show, it's is, I come back. Yes. Yes, I'm coming.
No problem.
Sorry for all these things. I would have done it. I would have done it from my office, but I have also a health issue, and I'm going tomorrow.
No problem,
Stavros.
Actually, we do really appreciate your problem-solving skill. It was brilliant, this screen sharing.
Yes.
So, no problem at all. Yes, okay. You see the screen again.
So,
very good.
So I come back. And let me show you that now something that it is done by Elena Pian. We see this event that started seeing, and you start seeing the spectrum of the light coming days and months afterwards, starting from the first second. After 2 months, we will be seeing that. So we saw an event that happened millions and millions of years before. Second per second, we were able to understand how it evolved. This has never happened before in astronomy. That's why we are the first global observation in real time. And we learn a lot of things, how the neutron stars have made, how the elements, including gold, that was a very catchy thing to say, are made. And then, of course, the structure of the jets. And among all, I mean, a very funny thing, we also saw these events. They are such that we call them cosmic sirens. Siren is another cosmological, very interesting thing about sonification. And why call them cosmic sirens? Because by measuring them, we understand the dimensions and the evolution of the universe, but I don't have the time. So we start understanding the universe not only through the living stars, but also the dead stars give us a new cartography, and this is great. And this physics will affect every part of fundamental science: cosmology, particle physics, astrophysics, nuclear physics, testing quantum mechanics, as we've heard before, and many, many other things. So, coming very fast to Virgo interferometer, in the last 3 or 4 minutes, I will talk to you about what the program we're having, which is, of course, as you know, not very far from Genova, is in Pisa. And how do we see it? It is this light interferometer, it's called. And what's happening is that you have the light that goes and being split in 2 arms. You see it below, how it happens. And the 2 arms have equal length. And the length is 3 kilometers, very long. And they are in vacuum, the highest vacuum on Earth, together with our American friends. And then they do interference, as we say in physics, but the interference is destructive. That is, light plus light gives us darkness. When the gravitational wave passes, these mirrors at the end of these 3 kilometers start moving, and the movement of these mirrors will make that we'll start seeing light where we were seeing darkness. And the analysis of that is the analysis of our signal, what you just saw before. And you make an analysis, which is now jargon called Fourier transform, and then you have again, here, I mean, sorry for the high-level physics, supposedly, it is from 10 hertz to a kilohertz, and the 10 hertz, the main background is the Earth, is the environment. It is the passage of the clouds. Everything that moves can affect our mirrors because we want to measure something which is 1/1000th of the diameter of the proton, as I said. So one of the things we do here, which we like a lot, is that we have a lot of connection with geologists, with sea wave people, that meaning ecologists, radio, electromagnetic wave people, anthropogenic noise, atmospheric. We can see the passage of a cloud can affect our taking of data. So we have a lot of interdisciplinary agreements and work with them. And one of the things we're doing, and this is an introduction in the next, is that we have in I showed you a signal of a gravitational wave before. Other kind of signal, you see it below, it is what we call glitches. It's a bloop, a broom. And this broom, it's either, most probably, most of the time, it is let's say, environmental effect, but it could be, why not, a supernova. And therefore, also we have developed a very strong program, which starts from citizen science, I would say a few things, and a big program on arts and science, and I will concentrate on that. So Reinforce is the program that we're doing, where it tries to look at interdisciplinary scientific knowledge with the support of citizens in a two-way process. Multisensorial and multi-messenger understanding of the cosmos go beyond the visual. Inclusion and diversity, where of course extend the participation to visually impaired, for instance. Critical thinking, how do you separate? Dyson has said, the biggest problem of the world is how you separate noise from signal. So how you can have also critical thinking in a world of increased digital connectivity. We collaborate with Nobel Prize people there. And then paths traversing traditional frontiers of the mode of apprehension of reality, cognitive and the affective, art and science. So we use a platform called Zoo Universe, where we have put 4 things: our gravitational waves, a deep sea observatory called Kilometer Cube. It has in Italy, it is outside Catania, and in France, outside Toulon, CERN, and also using, for instance, muons to look what happens inside the volcanoes. And another big asset of our program is the following. We try sonification, as I said. And we are very happy. In a few months, we will have Wanda Mercedes Diaz coming with us and start working with us for at least 2 years and hopefully much more. I encourage you to go to listen to her TED talk, how you sonify the universe, and it is fantastic. And so we are really proud to have her. And she told me once, Stavros, you seeing people tend to either linearize a thing, that is, you see something you expect to go higher or lower, or you stationarize. In our jargon means you expect the same periodicity, the same frequency to come, and all the rest you think it is noise. But for us blind people, the slight changes of rhythm can be significant, can be something beyond noise. And this is what we are doing in our program. We try to characterize, see, for instance, we use these glitches that I said, they are either things that happen, it's around environmental, or it could be a signal, and we sonify them. So for 2 things. Of course, for inclusion, to have the blind people help. But I believe, and this is where we'll try to make a full study, that we will increase our perceptual possibilities because of that. You hear some sonification here. And of course, we have a big part where we try to sonify according even to the harmonic scale. Going back to Pythagoras. So where you put the sea, for instance, it is the notes of the sea. So there will be the option of the people working on that, on how they will sonify and what would give them higher perceptive capabilities. Another thing that I don't have time to pass is, again, in the bottom of the sea, Kilometer Cube, where, again, seeing the neutrinos is, the noise for seeing the neutrinos comes from bioluminescent organisms or cetaceans, either dolphins or whales. So we have of the order of 15 years of data on that we will try also to use to understand the life structure of the deep sea, because this thing is 3 kilometers below the atmosphere. Last but not least is our program of art and science. I will not go through that. There is a fantastic, I hope you can see afterwards if you have the slides, you can go and see for all the exhibition that was called Il ritmo dello spazio that we made here in the Museo della Grafica in Pisa, where you see big artists, Saraceno, Lillian Lin, many others, trying to sonify. And we hope, of course, to have the previous 2 colleagues with us. And the only thing I would like to show you here is that we had people with Alzheimer that came. No, not yet Alzheimer, going towards Alzheimer. And by seeing, for instance, a black hole and around something explaining a black hole, they wrote this poem, which is, I don't know, I let you read it. It is fantastic. It is the affective comprehension of what is a black hole. They were facing a black hole in their lives coming. They were entering a black hole, loss of information. And still you see riflessione nucleo sferico, globo forma, nero, terra notturna illuminata della luna, abisso pieno vuoto, liscio, mistero esoterico, ragione, emozione, inquietudine, oppressione, freddo, pupilla di polifemo. Fantastic. And these are people that these feelings were created, but what they saw. Yeah, here you have some, it's also Bernard Lamarche, Attila Sorgo, and other people de la Porta. I don't want to pass on that. Unfortunately, due to the COVID, we had the offers for Paris, even the Exploratorium in San Francisco, which is a big thing. We had an offer, but still we'll see what happens afterwards. And there we put the phrase, scientists and artists are the world's noticers. Their job is simply to notice what other people cannot. And our hell is against illustration. As I've read somewhere in Leonardo, he said, the church wants us to illustrate. We artists, we're not illustrators of the church. We are different people. And the same thing can be said sometimes from science. We don't want the illustration of science. We want increase the things we can understand through that. Okay, this is a global network, not only in Pisa, but also in the US and in Japan, and soon, hopefully, in India. And we have, again, the story of the multi-messenger, a lot of frequencies, from the very small frequencies up to the frequencies we see in ourselves. And the next 20 years, we will go deeper and deeper into the cosmos and try to approach really these very first beginnings of the universe. So wanting to end, something I always like is that where the cosmos in Greek means order. And I was, sometime I was with Andrei Linde, who is let's say, one of the big people that invented inflation, the beginning of the universe of Big Bang. And he said, people call me cosmetologist, and I don't like it. I said, yeah, Andrei, they are right. They are right, because first beauty, cosmos was first beauty, and you have this fantastic, I don't read, fantastic text about Hera being dressing herself, and at the end she says, when she thus arranged around herself her cosmos, she left the room. And Aetius tells us that Pythagoras was the first to use the concept cosmos to describe the totality of things. So we took it from the aesthetic and we made it a scientific concept. And when I sent all this to Andrei, he said, thanks a lot. I always thought that cosmology is very sexy, but now in such a poetic representation, my suspicions became reality. Thanks so much. So it's not only a spatial order. Plato said rhythm is the order of movement. And the last thing, it's a philosopher that lived in Paris and died very young. He said, for the antiques, and this is what we try to do again, but with different data and with different environment, that cosmos does not signify only the universe, signifies time adornment and splendor, and the totality of beings and political constitution based on the law, principle of order and harmony, which regulates both the relations between beings and between the elements of each being. Virtue, or the good immanent in each being, and namely to become what it is and maintain itself as it is. And so this is, for us, our I'm sorry, I will show you, I finished, don't worry. This is what, this is what I always say that we do in Virgo. It is that we address the four cosmos that you just heard. We address the universe. Come on. It is, I put in, unfortunately. We address, I will show it like this. We address the universe through the multi-messenger exploration of the two infinities. We address the Earth. I talked to you a little bit about geoscientific, atmospheric, biological exploration of the environment, society, the anthropogenic impact and critical thinking, and the human, the multisensorial apprehension, art and science, and inclusion. So thank you, and thank you for your passions. Finished.
Thank you, Stavros. The technology didn't help you, but you solved all the problems. Okay. I found a very good connection between universe, human with blind people project, and the human that was introduced in the first session by Antonio. Thank you, Stavros. Thank you.